First row is fine as it is. I'm going to use row 1 twice to get rid of these two, get these two to 0. So use row 1 twice. So I'm going to use row 2. So this row, if I take away twice row 1, and this one will give me a 0. 2 minus 2 is 0. And in this one, I'm going to use row 3, take away 3 times row 1. And that should end up with a 0 there as well. So let's do that. I know this is going to be 0, because that's the way I constructed it. Row 2 is minus 1, take away twice 2 is minus 5, I think. Row 2 is 1, take away twice 1, which is minus 1, I think. 8, then take away twice 3 is 2. Yeah, correct me if I made a mistake.
Minus 1. No, it's not. Oh, yeah, it's good.
Thanks. All right, it's all good. Okay. This one, I know I'm starting with a 0. That's why I designed it this way. Row 3 then is minus 4, take away 3 times that. So that's, minus 10, is it? Minus 10. 1, take away 3 times 1.
There are no solutions. No solutions.
There are no solutions.
Yeah, no solutions. Really?
18. Wow, we're getting there. 18 minus 3 times 9.
18. Oh, wait, it's all be zeros. It's going to be 0,
Yeah,
0, 0.
how do you know this?
Okay, we don't know. We don't know. Some of us know, but a lot of us are going, what's going on? What do I do next? Try and get this last line a 0 here, yeah? So I'm going to use row, so this one's fine. We'll just leave this as this for the moment. And then I'm just going to use row 3 and 2 now to get this to a 0. So I'm going to use the new row 3, add or subtract twice row 2, yeah? The 10s should cancel, yeah. So what do we get? I get a 0. I wanted a 0. That's what I designed this as. So this is the first one I really have to calculate. This one, minus, oh, that's 0. Okay. This one, row 3. Oh, sorry, this one.
Sir, because you multiply by 2, not by minus 2.
4, 5.
Otherwise, you won't get to the 0.
Yeah, I need to subtract it. Yeah, multiply by minus 2. Yeah.
Why don't you do
Minus 2 plus 2. Yeah. Row 3, I can do it the other way around and subtract it, but you'll get the same answer. 9, take away twice this is 5, isn't it?
Yeah.
Okay. We've come to a place where we should now know, well, maybe not yet, but we should know in the future to halt and go, something's wrong here. This says basically that z times 0 equals 5. And that's impossible. So what would we say?
No,
There's no solutions.
although the bottom one's going to have infinite solutions.
Yes, of course. Yes, you see the way it's going. So there's no solution. As soon as you get the 0, 0, 0 number, that means no solutions. And that's what you would write if it was an exam question. There's no solution to this system of equations. There's no...
An easier step to get it. If you look at the second one, and you multiply the second row by 2. If you multiply the second row by 2, you will get minus 10 minus 2 equals 2.
if you see it... At what stage did you see it? You probably could see it at this stage. You can just, look, that's like, you could think like parallel, maybe. But no, that this is a multiple of this one, yes. Okay, let's do the second one then. 2, there's a shine there. 2 minus 1, 1 and 5, is it? 1, 1, minus 1 and 2. And you'll get good at this. 3 minus 3, maybe not Priyanka. 3, I mean, no, I'm joking. All right, okay, so this one, let's do our thing. So let's just get the zeros in first. So let's leave this 2 minus 1, 1 and 5. Make this one a 0, so I'm going to use row 1. So I'm going to say twice row 2 minus row 1. So 2 times that minus 2 is 0, which is what I want. Let's finish this row and then we do the last row. Twice this take away this, so that's 2 minus minus 1, which is 3. Negative 3. Twice this, 4 minus 1. Okay, let's do the last line then. Oh, there's a 3 and a 2. It's a bit awkward, but we'll do it. Twice row 3 minus 3 times row 1, or the opposite way around. Okay, so that's 0. I don't even have to calculate it because that's the way I set it up. Twice this is negative 6. Plus 6 plus 3?
Wait,
Negative 6. Negative 6 plus 3 is 3, yeah?
Oh, that's a minus. What? Negative.
Negative 3, sorry, yeah, sorry. Yeah. Twice row 3, 9. 9, 6, 6, 6. Twice row 3, 6 minus 3 is 3. 8.
16 minus 15, 1.
Let's just make sure twice is 16 minus 15 is 1. Okay. You could probably see at this stage, some of us may be able to see there's a similarity between these two lines. That when I subtract them. So 2 minus 1, 1, 5 is that first line, that's sweet. Let's just leave this as this for now. Don't need to get these to 1 at the moment. We do need to get this to a 0, which means I need to go row 3 from this line, row 3, yeah, plus row 2. So I get 0. These two added get 0. These two added I get 0. And this is our, there's infinite solutions. With the information we're given, yes.
But like, isn't that just common knowledge? 0 times anything would equal to 0.
But that's why.
So why does that have to?
Yeah, so it yes.
There is no z.
Okay, so what we got here is we basically don't have, if there's more information, maybe there is a unique solution, but with the information we've got, there's infinite solutions at this stage. Because we don't have any more, you got too many possibilities for z. Because everything times 0 is. So what we do in this case is we go, well, instead of saying z is just z, we say z is this like some t. It was a bit like when we had this yesterday. X plus y is 6. So if I say, right, if x is some number, what would the other number be? Y would be 6 take away t. And that's kind of like the set of solutions. You could say, right, t and 6 minus t would be my point. On all the points would follow this as a set. As in, if I knew t was 4, well, y. If I knew that x or t was 4, then y would be 6 minus 4, which is 2. And that makes sense because 4 plus 2 is 6. So you get a set. It's not very specific, but there's a load of solutions that will work. And this is the set of solutions then. Does that make sense? Yeah. There's loads of solutions to this, and it always follows this pattern. One is t, the other is 6 take away t. Okay, we're going to do the exact same here. We're going to say, well, z is t, and then we're going to figure out what they're all in terms of t. So at least if I knew what t was, I would have all the solutions.
Would you have to do that?
Yeah, this is how we show the solution. We just don't say all solutions. We give a bit more information saying, well, if I knew this z was t, then I also would know what y is and x is straight away. It's like,
Wait, so what would you write? You just say,
I haven't finished yet.
oh.
Right, I'm saying z is t, which means I can look at this second line and say, this second line reads 3y minus 3 times t now, instead of z, is equal to negative 1. And if I rearrange this y, 3y is equal to 3t minus 1 in terms of t, then I have something similar to what I have over here. I know it's not as easy, but it's what y is in terms of t. So as soon as I know what z is, I can find what y is, and then I would also have to find what x is, which is using the first line.
So why don't you just keep the z as z? Why do you have to change it to t? So why don't you just do 3z minus
Well, that suggests is that there's only one answer for z and not a bunch of answers. Yeah, so it's calling it z means, oh, this is what z is. Okay, so then, yeah, there's a bunch of answers. 2x minus 1 times this, It's not a very nice way to write it, but it's with the information we have. If we had more information, there may be a solution, but we don't have any more. Where are we at? Oh yeah, sorry, I'm looking at this line. So I'm using this line, 2 times x minus 1 times what y is now. Z we call t, which is easy to deal with, plus t is equal to 5. And we just rearrange this so x is also in terms of t. And then we will be done. We will have a point where they all meet, a bit like what this is a point where that's on this line. Haven't finished yet, so I need to say 2x is equal to, let's have everything on this side so it's a little bit easier. It's a bit annoying. That's 3t. 3t minus 1 over 3 plus t plus 5. Maybe common denominator on the right-hand side here will help me. 3t minus 1 plus 3t plus 15. If I put them all over 3, does that follow?
6t
Yeah.
plus
6t
14.
plus 14 over 3, divided by 2 then. X is 6t plus 14 over 6, but of course that can simplify a little bit. If I divide everything by 2, x is, what is it? 3t plus 7 over 3. So there's my 3 answers. If it is, so you kind of don't want to get the bunch of zeros because you know there's more work to be done then. It's not as easy as just subbing in a number. You sub in a variable. So if t happens to be 2, then we can get an answer for y and for x. Yeah.
Do you recommend maybe on the first one when finding out y to do t minus 1 over 3 instead of 3t minus
Oh, you could have, yeah. If you find that easier. I think it's as easy to do it both ways, yeah.
So really, if we're trying to do as like as least work as possible, the only, like we don't need to get 1, 1, 0. Like it doesn't need to be 1, 1, 1 like diagonally across.
No.
So it just doesn't. You just need to have like zeros in the corner. And then
Yeah,
you do-
so, yeah, like when they say row echelon form, which is kind of what we're doing, which is just the name of this system, it is finished when it's at 1, 1, 1.